Okay, so first things first, you're given an equation or a function, however you want to call it, and you need to be able to pull out the amplitude. Whoa, come on, oh there we go. Amplitude, period, if there's a reflection, phase shift, and vertical shift. So let's break down each piece of a function or equation, how that looks. Let's see. We got a sine or cosine of, let's see, bx minus c plus d. A, the number that's in front of your sign. That's your amplitude. Yep. So if there's no number there, then it's one. So like the first, well, I mean I know the numbers are off, but the first one, the second one, I'm sorry. Yeah, sorry about that. Who said that? Who said that? No, I'm just saying, who said that? You? Because somebody just called me out on a mistake. If you call me out on a mistake, I give you a piece of candy. I was saying, who said that? Okay, I'll give you a piece of candy. Anyway, amplitude. Amplitude is one for the first one, the second one, the third one, and the fourth one. Or excuse me, the sixth one. Whoa. Come on, man. What the heck? What are y'all doing to my stuff? Oh man. No, I'm about to. Yeah, the amplitude is always positive, but I'm explain the negative in a second. Come on, man. There we go. Okay, so the amplitude for the first one, second one, third one, and the sixth one, they're all one. The amplitude for the fourth one, or number 8, is 2. And then the amplitude for the 9 or the fifth one is 4. Now let's talk about the negative. The negative tells you if you have a reflection or not. They don't care. You don't care about the amplitude. The negative just tells you if you have a reflection or not. So if there's no negative, there's no reflections. This is no or NA. So there's no negative for the first two. So NA or nope or no or however you're going to say it, or none. But for the seventh or the third one, that's a yes. There's a reflection. For the 10th one or the sixth one, however you want to say this mess. Say it again, sir. Yep, 7, 8, and 10. I might as well just use the numbers that's there. Yes, 7, 8, and 10. What's your question, Makai? Okay, so those negatives just mean you got a reflection. Now, next, if you've got a number that's multiplied times x in your equation, that's your frequency. Now, notice frequency ain't up there. As you can see, frequency is not up there. But what you do is, to get your period, you use the frequency, because period equals 2 pi divided by the frequency. So, say it again. So actually, for the first one, for number 5, it's actually 4 pi, because that's 2 pi divided by 1/2. And what kind of a problem is that? That's a keep, change, flip. Excellent. So then that's 2 pi times 2 over 1. So the period for number 5 is 4 pi. So even though frequency is not on there, you need to be able to call out the frequency. That's why I wrote this thing right here. A is your amplitude, B is your frequency. So whatever numbers times X, that's your frequency. So like for number 6, frequency is 1. So then your period is just 2 pi. You know, if there's no number that's multiplied times X, then your period is just 2 pi. Does everybody follow what I'm saying? Am I going too fast? I mean, I can slow down a little bit. Okay. Yes, sir. So like for number 6, there's no number being multiplied times X. So the frequency is 1. 2 pi divided by 1 is just 2 pi. So right here, just like number 5, my frequency is 1/2. So I've got 2 pi divided by 1/2. Keep, change, flip. So the period is 4 pi. For number 8, yeah. Okay. Yep. Keep, change, flip. Because this is 2 pi. divided by the frequency. Yo, can we not do all that? Y'all too noisy. It's still too noisy. Okay. So the period is 2 pi divided by the frequency. So the frequency is something that you can see in the equation. The period is not something that you see in the equation. You got to figure it out. So frequency for number 7 is 1/2. Yes, ma'am. So then that's 2 pi divided by 1/2. 2 pi divided by 1/2 is 4 pi. Yes, ma'am. Because it's keep change flip. Yeah, the period. Right where? Number 7, that says 4 pi. Here, let's see. Does that make it better? Okay. Okay. So then, what's the period for number 8? It's not -2. What's the period for number 8? It says 2 pi. All right. What about the period for number 9? It's just 2 pi. And then what about the period for number 10? 2 pi. Because whatever's multiplied times x is your frequency. You take 2 pi and divide it by the frequency to get your period. Okay. Yep, in front of that. All right. What? Give me a minute, I'll explain. One thing at a time. Excuse me. Hey, I'm trying to record this. Y'all making too much noise. I'm not telling you to shut up, but y'all are making too much noise. Anyway, we got phase shift and we got vertical shift. I said I didn't tell you that. Phase shift. All right, phase shift comes from C. So you should have parentheses and then something after your X. So like right here for number 5, there is no phase shift because there's no parentheses. But then number 6, there's parentheses. So my phase shift is pi over 4. Now, nope, that's why I'm getting there, ma'am. Notice that when I wrote this equation down, it says minus C. C is your phase shift. The equation is expected to be minus. So when I look at what the phase shift is, it's just that. It's just pi over 4. It's not minus pi over 4. All right? And that's going to come into play when you get to 10. So if I look at number 7, there is no phase shift because there's no parentheses. So no phase shift. Whoop. Come on, man. No phase shift. NA or none. When I look at number 8, there is because there's parentheses. It's pi. It's just pi. When I look at number 9, there's parentheses, so there is. It's 3 pi over 2. Yep. You'll be all right. So anyway, last thing for this is vertical shift. Vertical shift is D. Okay? So notice I got plus D. Yes. Oh, I'm sorry. Oh, you piece of candy. Anyway, so thank you, because number 10 is different. I'll look at number 10. It says plus pi over 2. It says plus pi over 2. That means my phase shift is negative pi over 2 because the formula wants it to be negative. So if it's positive, you know. So thank you, bro. So anyway, now the last one, vertical shift. Yes, ma'am. Because right here. Okay. Excuse me. 7 doesn't have anything in the parentheses, so it doesn't have a phase shift. But 6 does. See how that's in parentheses? So whatever I'm adding or subtracting, that's going to be my phase shift. I want, okay. Okay, because it's plus here. Look at the formula that I wrote. Formula says minus C. If it says plus, then that's negative. Okay. So vertical shift. That's just if you got a plus or minus at the end. So vertical shift for number 5 is just -4. Now that one, you take it as you get. If there's no parentheses, take it as you get. -4 means it's a -4 for vertical shift. For number 6, there's nothing outside the parentheses, so that's NA or nope or none. Right here for number 7, I got +3 at the end, no parentheses, so that means it's a vertical shift of 3, or +3 if you want to be technical. If I look at number 8 don't have anything outside the parentheses, so that's NA or nope or none. Then I get to number 9. What's my vertical shift for number 9? Say it again. It's nothing. Yeah, there isn't one. Exactly. There's NA or nope. And then I get for number 10, I got 1 at the end. So that's a 1. I guarantee you, whoop, 1, sorry. I guarantee you'll see something like that that's got all of it. And then you'll see a couple that are like, that's got some, but not all of it. Okay? Does anybody have any questions on this? We got this I would suggest you write down. Yes, sir. Yes. Yes. Go ahead. What's up? Ask. Okay. So anyway, right here, I would suggest you write this down. This formula right here. I think I'm gonna make a video for note card suggestions too. So I'll have that stuff. So anyway, does anybody have any questions or can I move on? Yes. Oh, okay. Anybody questions or am I moving on? Okay. All right. Let me make. Yep. Okay. Go ahead. Mm-hmm. Yep. Okay. So real quick, sine graph looks like a sideways Z or a weird looking backwards S. Okay. And like man, I can't think of shoot. Thank you, Jada. Like Jada said, it starts at the origin. Okay. Starts at the origin, gives you either a backwards S or like this weird sideways Z. Cosine's graph. It starts high, hits the middle, ends low, and then goes back high. So it looks like a weird, like a V or a U. Okay? So that's what the sine graph looks like, and that's what the cosine graph looks like. Now, there's with phase shift and vertical shifts. That changes the way it looks slightly. But so um so let's work with what we got here. This is a sine graph, right? All right. Next, I want to know what the amplitude is. What's the amplitude? The amplitude is 3. The amplitude is how far it is from the midline to your highest point or the midline to your lowest point. So I'm looking at number 10, bro. So my midline is right here. So my amplitude is 3. What about my period? It is actually pi. Because look, my whole graph goes from here to here, and it ends right there. I mean, my fault. It ends right here. Yes, ma'am. Okay. Yeah. Kayla?
Yes. Thank you for doing this.
Yeah.
I know that Miss Tipton was worried about it.
It's fine. We were talking about doing it anyway.
Okay.
Matter of fact, I'm recording for so the kids that aren't here can see it too. There you go. Okay. So were you asking a question? Okay, what's up? I'm explaining. Okay, I'm gonna say this again. The graph for sine looks like a sideways S, right? So if I look here, okay, definitely didn't need that. If I look here, it's like, okay, I need you to quit being thirsty on the instructor. So anyway, if you look right here, it's like I got two cycles of the graph, right? That pi is supposed to represent right here, and 2 pi is representing right there. So 2 pi is how the graph that's usually a period, one solid cycle. But this one, it's like it got scrunched up. So it's got one cycle from 0 to pi, and then another cycle from pi to 2 pi. So that tells me that my period is pi. Because this right here is the frequency. So if I said the frequency was 2 pi divided by 2, it would be pi. So, but we're looking at the picture, not the equation. So, do you understand what she just said about the frequency? Frequency is how many cycles you can get between 0 and 2 pi. There's 2 cycles there, so the frequency is 2. So, if you wanted to know, if you were going from like this, 2 pi divided by 2, the 2's cancel off and you get pi. So that's where my period is pi. Okay. Because I know that the cycle for a sine goes like that, and there's one cycle there, right? And so, like I said, that pi is supposed to go right here. Like for instance, if I look down here real quick, that's one whole cycle, but it's not, 2 pi is right here in the middle. So I know that whole cycle, it took longer than 2 pi to get one whole cycle. You know what I'm saying? Okay. That's how I knew from the picture. Okay, so like I said, the frequency is 2. I would suggest that you always write down the frequency, whether it's there or not, because the frequency helps you for your period. It also helps you for your equation. The frequency is 2. How many cycles you get between 0 and 2 pi? Yes, kind of, but you want to be careful about that. Yes. What? Yes, because it's dollar store paper towel. Okay. So anyway, hey, I'm trying to record this. Can we chill with the paper towel talk? So anyway, so the period is pi. And now I want to do the equation. Yep. 3 sine. And then what's my frequency? 2 and then x. That's it. That's why you want to know the frequency. See, for when you're trying to get the period, you want to know the frequency because it helps you because you divide or whatever. It gives you the period. But when you're trying to write the equation, the frequency is the actual number that you write in the equation. That's why you want to know it. Is how many cycles of your graph that happens between 0 and 2 pi. So right here, it's fine. So here, see I got a red one and a blue one? That's 2 cycles that happen between 0 and 2 pi. So because that's 2 cycles, my frequency is 2. Nope. The next one will be 1. Because here it goes, it ends at 2 pi. One cycle ends at 2 pi. Even though the graph is bigger, one cycle happens between 0 and 2 pi. Yes. Don't worry about that. You got a new card? Here. There you go. Okay. What don't you get? Go ahead. 1 second. Excuse me. Thank you. Let's go ahead. Okay. Hold on. Yeah? I'm listening. Go ahead. The period for which one? For 11? The 11? Yes, it's 2 pi. What were you saying, man? Mm-hmm. You want to look at how many wavelengths you have between 0 and 2 pi. In this case, I've got I've got one wavelength between 0 and 2 pi, so the frequency is 1. I say cycles, you're saying wavelength, it means the same thing. Yep, no problem. So the frequency is 1. What's the amplitude of number 11? 4. All right. What's the period? The period is 2 pi. It just be x because the frequency is 1. Okay. And then right here. So how many wavelengths or how many cycles can I get from 0 to 2 pi? I just got half of a cycle. See, there's the whole cycle. That's sine, but I only get half of it, right? So then that'll be my frequency is 1/2. The amplitude is 2. Yes. Okay. Okay. Again, I'm looking for wavelengths or cycles between 0 and 2 pi. This is my sine graph right here, right? It's that weird sine with z. The whole graph is 4 pi. When I get from 0 to 2 pi, it's only half the graph. So I got half a cycle or half a wavelength. That's my frequency. Nope. The first one that we did, I got 2 full cycles between 0 and 2 pi. For this one, I got half a cycle. All right? Nope. Okay. For period, you divide. 2 pi divided by frequency. And so, but see, the other thing is, we're given the equation here. They're asking us to write the equation in here. So you need the frequency to write the equation. That's why you need to be able to recognize what the frequency is. You need the frequency to find out what your period is when you are looking at an equation. So you need to recognize what the frequency is. So even though you'll hardly ever see frequency in some problem like this, you need to be able to recognize what the frequency is because you use it both ways. The period is 4 pi. Okay, so I was right. Yep. The equation should be y equals 2 sine 1/2 x. Yes, ma'am. So the period right here is 4 pi because it took 4 pi to get one whole wavelength or one whole cycle. And then equation is y equals, like the lady said, 2 sine 1/2 x. All right, and then the last one. All right, what kind of graph is this? It's a cosine graph, but it's something different about it. What? No, that's not that. It's negative. The amplitude is still 5. Yep. All right. Say it again. The period will be 2 pi because look, one cycle. Okay, here's the thing. It's a reflection. Hold on, hear me out. It's a reflection. All right. That's how. Okay, that's kind of messed up, but that's how a regular cosine graph looks. Okay. That's how a regular cosine graph looks. A reflection, it looks like that. And that's what we got. But still, it started low, hit high, and ended low. That's one whole cycle or one whole wavelength from 0 to 2 pi. So my period is still 2 pi. Mhm. Yes, ma'am. It's not 1/2. It's y equals, like you said, negative 5 cosine x. Now, I'm going to tell you right now, none of these graphs had a phase shift or a vertical shift. Well, they had a reflection. But yeah, yes, the one we just did. Okay. Right here. This is my equation, right? 1/2 is the frequency. How do I find the period? Period is 2 pi divided by the frequency. So that's 2 pi divided by 1/2. Keep change flip. So that's 2 pi times 2. That's 4 pi. That is when you have an equation, how we get the period. But then if I have the graph, this is how it would look if my period is 4 pi. One whole cycle with a graph goes from 0 to 4 pi. That's one cycle. Okay? Maybe.
It's not by choice, it's by force.
Okay. Well, hold up.
It's not by choice, it's by force.
Okay.